Secant, cosecant, and cotangent are closely related to sine, cosine, and tangent. Keep watching to find out how. Welcome to Math Bytes. I'm Allison, and today we're talking about secant, cosecant, and cotangent. Three of the trigonometric functions are sine, cosine, and tangent, and the other three are their reciprocals. So we have our three trigonometric functions, sine, cosine, and tangent. The cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine, and the cotangent is the reciprocal of the tangent. So just to remind ourselves, for an acute angle theta, the sine of theta is equal to the length of the side opposite divided by the length of the hypotenuse. So the cosecant is equal to the length of the hypotenuse divided by the length of the side opposite. The cosine of theta is equal to the length of the side adjacent divided by the length of the hypotenuse. So the secant is the length of the hypotenuse divided by the length of the side adjacent. And the tangent of theta is equal to the length of the side opposite divided by the length of the side adjacent. So the cotangent is the length of the side adjacent divided by the length of the side opposite. Let's do an example, and I'll show you how when you know just one of these function values, you know a lot of information. So keep watching. Okay, let's take a look at an example. Alpha is an acute angle of a right triangle. The secant of alpha is equal to 3 over 2. Find the sine, the cosine, and the tangent of alpha. All right, the secant of alpha is 3 over 2. That's equal to the length of the hypotenuse divided by the length of the side adjacent. So let's draw a right triangle so we can see this. So here we have our right triangle, and the side adjacent to alpha is 2, and the hypotenuse is 3. So we need to find the missing side, that side B. We don't know that length yet, so we need to find that, and we can do that using the Pythagorean theorem. The Pythagorean theorem says that a squared plus b squared equals c squared, where c is the hypotenuse. So in our case, that gives us 2 squared plus b squared equals 3 squared, or 4 plus b squared equals 9. Subtract 4 from both sides, we get b squared equals 9 minus 4, which is 5. Take the square root of both sides, and we get that b is equal to the square root of 5. Okay, now we have all three sides of our triangle. All we have to do is plug in the values. So the sine of alpha is equal to the length of the side opposite divided by the length of the hypotenuse. So that is the square root of 5 over 3. The cosine of alpha is 2 over 3. And you'll notice that's the reciprocal of the secant we were given at the beginning. And the tangent of alpha is equal to the length of the side opposite divided by the length of the side adjacent. So that is the square root of 5 over 2. So just by knowing the secant of alpha, we were able to find the values of all three of these trigonometric functions. Let's take a look at another example. Given that the sine of 60 degrees is the square root of 3 over 2, the cosine of 30 degrees is the square root of 3 over 2, and the tangent of 45 degrees is equal to 1, find the cosecant of 60 degrees times the secant of 30 degrees plus the cotangent of 45 degrees. All right, we're going to use the fact that secant, cosecant, and cotangent are reciprocals of sine, cosine, and tangent in order to determine their values, plug them into this expression, and evaluate. Okay, so the cosecant of 60 degrees is equal to the reciprocal of the sine of 60 degrees. So that would be 2 over the square root of 3. The secant of 30 degrees is equal to the reciprocal of the cosine of 30 degrees. So that's also equal to 2 over the square root of 3. And the cotangent of 45 degrees is equal to the reciprocal of the tangent of 45 degrees. And the reciprocal of 1 is just 1. So now we have all our values. Let's plug them in. So we get 2 over the square root of 3 times 2 over the square root of 3 plus 1. Just like any other problem, do order of operations, multiplication first before addition. So 2 times 2 is 4. Square root of 3 times square root of 3 is square root of 3 squared. It's just 3. So we get 4 over 3 plus 1. We can turn 1 into a fraction of 3 over 3. So we get 4 over 3 plus 3 over 3 equals 7 over 3. So this expression evaluates to 7 over 3. When you use right triangles to define the trigonometric functions, you're only defining them for acute angles. And of course, we'd like to know what the values of these functions are for all angles, and that's certainly doable. But it's easier to understand them first using right triangles. Then it's not so hard to make that extension and see what the values would be for any angle, acute or not. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if you have a question for us, send us an email. We're at contactmathbytes@gmail.com, and we'll see you next time.